by manipulate rigid flow.
Watch as the voltage accelerates through the windings. We're aiming for 75 kilowatts while maintaining thermal stability. Thin silicon steel laminations minimize eddy currents. In comparison, the solid metal core shows significantly higher losses and wasted heat. Here we see the laminations compressed tightly by the heavy press machine, forming a solid and rigid stator core.
For large motors, the frame is often made of cast iron or fabricated steel. This is the outer shell of the motor that holds the stator. The frame for large motors is often made of cast iron or fabricated steel. This is the outer shell of the motor that holds the stator. The CNC machine performs precision boring and milling operations. This ensures a flawless inner surface and a perfect stator fit.
Mounted on the CNC machine, the large motor frame undergoes precision boring and milling. This process guarantees a smooth inner surface.
The insulation paper ensures complete electrical isolation, preventing short circuits between the copper windings and the steel core.
The process utilizes a vacuum to remove air, followed by high-pressure impregnation.
The VPI process begins with a deep vacuum.
The sensors clearly detect the rotor imbalance. As you can see on the data graphs, secure the connection with the torque wrench until it clicks. Then, gently tug the wire to confirm it is fastened correctly.
As the load increases, we can observe the corresponding rise in torque and current draw. The temperature remains stable within operating parameters.